When people start explaining what slope means, they typically start with a definition. So the definition of slope is the rate of change. In other words, slope tells you how much the y value changes when the x value changes by 1. How much is it moving up and down as you move right on the x-axis? To make it a little more simple, people may say, slope is how steep the line is, or how fast something is increasing or decreasing, or not even at all. But first, let's start with the definition. What is slope? A lot of the times, you'll hear that slope is something called rise over run. Now, what does that mean? Rise? Let's begin to associate rise with how much is it going up and down. I know rise is typically going up, but in this case, it means how much is it moving up and down? And of course, when we look at the x-axis and the y-axis, which one is moving up and down, the y-axis or the x-axis? Right, the y-axis. So rise signifies how much is it moving up and down, so the y-axis, the y change, over run, which is, of course, the x-axis. How much is it moving left and right? So this ends up being the change in x. So typically you may see in a more simpler way. I've used the triangle, which is delta, which means change in, but of course they probably will put it in a different way, which is called y2 minus y1, 2 minus y1. These little subscripts signify which point you're using. Are you using point 1 or are we using point 2? Now, as for which is which point, I'll go into it a little more in depth in the next section. So let's look at this graph. It's going up. Now, they will maybe just give you a graph that looks like this going up. But using our knowledge of math and coordinate planes, let's think about what coordinates we can put for this point and this point. Now this one is at the origin, so this one is easy. It's going to just be 0, 0. But if we look at this point, what is this? Well, we know this one's to the right of 0, so let's put this at 4. And this looks like the same amount, almost the same amount of space. And it's also going up, so it's positive as well. So let's say this one is 4 as well. It's greater than 0, of course, and they're moving to the right and up from 0, so they should also be positive. So let's put this point as 4, 4. Let's write it quickly. 4, 4, and then this one is 0, 0. Now let's go back to the formula. y2 minus y1 over x2 minus x1. Always memorize this. Rise over run is always change in y, so the y's are always going to be on the top, over run, which is changes in x. As for which one is 2 and which one's 1, 2 is always going to be the one to the right. This point is to the right, so we're going to use this one for 2. 1 is always the one to the left. This one is to the left, so we're going to use that one for 1. So when we look at this formula, how do we plug it in? First, we just take the coordinates. It's very simple. So this one's to the right, so this one's 2. Let's label it 2, 1. The y-coordinate is 4. The y-coordinate of 1, 0. The x-coordinate of 2, 4. The x-coordinate of 1, 0. So when we do this, 4 over 4, because 4 minus 0 is 4, 4 minus 4, 4 minus 0 is 4. So the slope is 1. So let's also look at this graph. If it's moving up, we have to see the pattern. If it's up, that means it's a positive slope. Because no matter what graph or numbers we put, as long as it's moving up, it's going to be positive slope. So we could have did 5, 5 or 6, 6 and would have also been positive. Now let's move on to another type of graph we might see. We might also get this graph. It's going down. What does that mean about slope? Well, let's think about numbers that could be for these coordinates first. We know that this is the origin, so this has to be 0, 0. And this is to the right of 0, so this is probably like 4 or 5, whatever number you want to put, that's greater than. And this looks like almost the same amount of space, so let's do this one as 5 as well. So let's mark down what these coordinates are. X value is 0, y value is 5. This one, the x value is 5, but the y value is 0. Now, let's look at the formula. y2 minus y1 over x2 minus x1. Which one did I say was going to be 2 again? The right one. So this one is going to be 2, and this one's going to be 1. Always choose the right one, both literally and figuratively, as coordinate 2. So let's do this. y2, 0, because the y coordinate for point 2 is 0, and then y coordinate for point 1, minus 5, and then 5 minus 0. So what does this give us? Negative 5 over 5. The slope is negative 1. So again, there's a pattern. When the slope is moving down, that means it's going to give us a negative slope. This is always occurring. And you have to memorize this because this is a common pattern. If you see the slope going down, it's a negative slope because it's decreasing. Now next, you might get a graph that looks like this. It's a straight line that goes simply right. What does this mean? Well, of course, we can always use coordinates. So here's the origin. Mark that 0, 0. And let's say that this is 5, because I like using numbers like that. So let's say this is 5, and this is maybe 7, right here. So let's put in these coordinates. This point is 0, 5. This one is 7, 5. So let's write the formula. y2 minus y1 over x2 over x1. Rise over run. Final versus initial. 2 is always the right one, the final. So this is 2, because it's the more right one. And 1 is always the more left one. So let's just plug in these coordinates. 5 minus 5 over 7 minus 0. So as I goes, 0 minus over 7, 0 divided by anything is 0. So the slope is 0. So why does this happen? Well, as I said before, slope is the change in y over the change in x. So if the x is moving, but the y isn't moving up and down, then the slope is 0, because the y isn't changing at all. And slope recognizes how much it is changing. So if it's changing by nothing, then the slope is going to say, oh, it's 0, because it's not even changing how much it's going up and down. And lastly, of course, they might give you a graph that looks like this. What does this mean? It's just a vertical line that's going up and down. How do we even get a coordinate for this? Well, a vertical line means it's undefined, because as I said before, slope means the change in y per change in x. But for a vertical line, as you can see, it's not even changing x-wise. So x isn't changing, and there is no per x, because slope is how much is the y changing per x. So if there's no per x, then we can't even define the slope. Therefore, we can't say how much y is changing per x, because we don't even have a per x. So that's why the slope is undefined. To sum it all up, these are the graphs that you need to know. If it's moving up, then it's increasing. And the slope should be positive. If it's moving down, then the slope is moving down and decreasing, and therefore should be negative. If slope is moving in a straight line like this, then slope is equal to 0. If it's moving in a vertical line like this, slope is undefined.